In section 10.6, there are two formulas that we use. The first one is the ordinary annuity formula, which tells us how much we can accumulate if we make payments, regular payments, of a certain amount of money at a certain interest rate and so forth. So let's work a problem. Determine the accumulated amount in an annuity if we invest $400 quarterly for 35 years at 8% interest compounded quarterly. So I've taken the numbers in the problem and I've put them into the formula right here. And so I'm going to pull up my calculator. Now on this one, the denominator is pretty easy, and I probably would just go ahead and calculate that and write it down, because that's just going to be 0.08 divided by 4 gives me 0.02. So that's a pretty simple number to remember. If I wanted in my calculator, I could go ahead and store that in the memory. I'm going to go ahead and do that, but it's a pretty easy number. Now I'm going to focus on the numerator. And again, I'm going to start right here. And I've actually got that quantity right here. I just calculated it. Then I'm going to add 1. And then I'm going to raise it to the exponent. In this case, it's 140. And then I'm going to subtract 1. And then I'm going to multiply by 400. And then finally I'm going to divide by that 0.02 that I had put in my memory, or I can just remember it. It's a pretty simple number to remember. And so here's the amount I can accumulate, $299,929.32. And I went ahead and I put the intermediate steps down right here in case you need to do that on when you do your calculations. So I did this portion here in the square brackets, put it down here for you, the denominator, and then finally multiply 400 times that quantity, divide by the 0.02, and you get an accumulated amount of a little bit more than $299,929. The other formula that's in this section is called the sinking payment formula, and this is where you figure out what the payments are you need to make in order to accrue a certain amount of money. So let's work an example. Determine the payment needed to reach $250,000 if the interest rate is 6% compounded monthly for 35 years. So again, I took my numbers into the formula, and I think I probably would start in the denominator here, because once I've calculated the denominator, I could store it, do the numerator, and divide. So let's go ahead and pull up the calculator. So I'm going to take the numerator, I'm going to start right here, 0.06 divided by 12 plus 1. And then I'm going to raise it to the exponent here, which if you multiply that out, it is 420. And then I'm going to subtract 1. And then I'm going to go ahead and store that in my memory. You could jot this number down. I'm going to show you that in a minute. Then I'm going to go ahead and do the numerator. So I've got the $250,000 as my goal, times 0.06, and then divide by 12. Again, pretty easy number in the numerator if you did want to do that portion first. And then divide by memory recall. And so my monthly payments that I need, $175, now I want to talk about this for a minute, 0.474. So let's just scroll down for a minute. And I put the intermediate steps here if you want to follow those. Now, we're going to go ahead and round this up to 48 cents because we want to make sure that we actually accumulate the $250,000. If we stayed at 0.47, which would be following rounding rules, if you used a formula to figure out how much you accrue, you wouldn't actually accrue the exact $250,000. So on annuity payments like this, just like we did with the monthly payment on the credit card bill, we're always going to round up.